Okay, so we have an example problem here that involves bearing. So let's take a look. Let's read through it first. An airplane takes off from a runway at a bearing of north 20 degrees east. So we want to eventually draw that. That's why we wanted to take a look at those sketches previously, so we know where to draw the triangle at. After flying 1 mile in this direction, the plane makes a 90-degree turn to the left. So we'll assume that an airplane can actually make a right 90-degree turn. We'll assume that. After flying 2 more miles in this direction, what is the bearing from the airport to the plane? So the first thing we have to do, we need to draw a triangle that relates this information. So first I want to draw north 20 degrees east. I'm going to try and draw this somewhat to scale with the 20 degrees. I'll make it look somewhat accurate. So I'm going to go 20 degrees this direction. So this right here is going to be my 20 degrees. It's going to be a pretty narrow angle there. I'm flying in that direction for 1 mile. Then it says I turn 90 degrees to the left. So that means I'm drawing another line out this way, and that has a right angle. And this says we're doing that for 2 miles in that direction. We want to know the bearing from the airport to the plane. So therefore I'm actually going to complete this triangle here. And so the triangle will definitely end up in the second quadrant. Now that I have this complete, I have to figure out the bearing. So bearing has to be measured from either the north or the south. So 20 degrees is this bearing, but that's not the bearing they're asking for. They want to know the one from the airport to the plane. So what I want is I'm going to label this with these 2 symbols here. That right there would be the actual angle we're trying to find, because the bearing is measured from the north or south. So I'm going to be going north and going that direction to the left. And I got to find out what that angle actually is. In order to do that, the best thing to do would be to figure out if I could find out the whole angle inside the entire triangle. Then what I need to do is just subtract 20 degrees from it. That'll leave me the rest of the amount left over. So I'm going to redraw my triangle. I have a 1 and I have a 2 here. And this is the actual angle I'm trying to find. The 1 right there next to the 1. That's the angle I want to find. So if I find that whole entire angle inside the triangle, that's the whole thing, then what I'll do is subtract out the 20. That will allow me to have this left over, and that's the bearing I'm going to look at. So let's do that for this one. This is my theta that I'm trying to find. I want to pick a trig function like before that relates the side I'm given to the side the 2 sides that I have given there, and that relates the theta that I have. So in this case I have an opposite and I have adjacent, so I want to use tangent. So let me put that right here. Tangent theta is equal to opposite over adjacent. So tangent theta is equal to 2 over 1. Now, we haven't looked at the problem like this yet in this section. Most of the time we're actually given a theta and we're able to multiply or divide and get our answer. This time it's different. This time we have a theta that we need to find. This is something that we'll talk about in another section, talking about inverses, but we'll talk about that now, how you're going to solve this. What you need to do is you want to clear out the tangent from this. And the way you're going to do that is you're going to put what's called an inverse tangent. You're going to put that on both sides. So I'm going to put an inverse tangent here. Now whenever you have an inverse and a regular one together, both of those automatically cancel out and you just get theta. So the only way to get rid of the tangent is by putting an inverse tangent in front. So I'll put an inverse here, we'll cancel out with that one. Now what you do to one side, you have to do also to the other side. We're going to take inverse tangent of 2. So now my answer becomes the inverse tangent of 2. I'm taking an inverse of both sides, that's what I did, to get rid of the tangent here so I get theta by itself. Now to do this part, you're going to use your calculator. Now right above the tangent key on your calculator you should have an inverse tan button, and you'll have to get it by hitting a shift key or a second key, and that'll allow you to get this. So if you punch that into your calculator, what you should get is 63.43 degrees. That's the inverse tangent of 2. So what I just found is I found the entire angle inside the triangle, this angle right here, was 63.43 degrees. That's what I just found by doing all this work here. But that's not my answer, because I want the bearing is measured only from here. So I'm going to take the whole entire angle inside, that's 63.43. I'm going to subtract 20 degrees from it. That's going to leave me the amount left over. 63.43 minus 20 is going to leave us with 43.43 degrees. So is 43.43 the answer? No, that's not the answer either, because it's asking us to find a bearing. So a bearing means that we need the directional letters. We need a north or south that comes in front and an east or west on the end. This is the angle we'll have in the middle. So we're going to go north, but then we're going to be going to the left. So I'll have a north, and then 43.43 degrees. And then since I'm going to the left, that's going to be west. So this would be the answer to the entire problem. We have north, 43.43 degrees west, and this is going to be the answer for this particular problem.